Late code 2751 robot collisions. So in this question, we are given two array, position array and health array and direction. So we are given three things and they actually denote a robot, right? If we see the first input, we have position, right? 5, 4, 3, 2, 1. And we have health, that is 2, 17, 9, 5 and 10. And finally the directions. So it's R, 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 R and R. Right, so what actually these denotes? So the first one, position, it represents the position of all the robots, right? Imagine there's like imaginary line, and in position 5th we have a robot, and then position 4, and similarly 3, 2 and 1, right? So in these position we have robots, all right? And this health corresponding, like the robot which is at 5th position has health 2. So he has health 2, he has 17 and 9, 15 and finally 10. And R is the direction, so he is moving to the right, he is also moving to right, right, right and right. So we have to identify if they keep on moving, right? There could be a possibility that they might collide. So after the collision, how many robots are left and what is their health? That we have to determine, right? Because in this scenario, if since everybody is moving in the same direction, they won't collide, right? If I'm moving one step, then this one also move one step, this one also moves one step, so they'll never collide. Let's take the another example. When position is 3, 5, 2, okay, and but position is 3, 5, 2, 6. Alright, we'll try to plot it. So one robot is at 2nd position, then one is at 3rd position, then 4th we have nothing, and 5th we again have one more, and finally at 6th we have the last one. And what are their health? 10, 10, 15, 12. So 10, 10, 15, 12. So the robot which is at position 3 has health, he has health 10, and 5th one also has 10, 2nd one has 15, and the 6th one has 12. These are their health. And finally their direction, so R, L, R, right, is moving to right, left, right, left. So the 3rd robot is actually moving to right, the 5th one is moving to left, and the 2nd one is moving to right, and the 6th one is moving to left. So these are their absolute direction in which they are moving. So if we see this diagram, right, we can easily see that the first collision that will happen, because everyone is moving in a constant speed, right? Everyone will move in a constant speed. So the first collision, we could easily see that it's going to happen between 3 and 4, right? Once they'll collide, then only there could be a possibility of another collision. So what happens when two robots collides, right? It's already given in the description of the question. What happens when they two collide? So for them to collide, one robot has to move to right direction and the another has to move in the left direction. Then only they can collide, right? This is the condition for collision, right? If one is moving on the left side, another is moving on the right side, so they won't collide because he is going this side, he is going this side. So in order for them to collide, they have to come in on each other, right? So this has to move to right and this has to move to left. Then only they can collide. This is the condition for collision we'll use while we write the program, right? And what happens when they collide? So three things can happen, right? Three things can happen. First one, let's say his health is 10 and his health is 5. In this scenario, when the whichever robot has the higher health, in this scenario, my robot 1 and robot 2. So whichever has the higher health, that will keep on, that will stay there and the other one will be destroyed. So if robot 1, that is R1, let's say, if his health is greater than the robot R2 health, then what happens? R2 get destroyed, and this robot 1, right, his health will decrease by -1. This is the condition. Whenever the two robots collide, if one is having a higher health, the other robot which has a lower health will get destroyed, right? So in this scenario, 2 will get destroyed and his health will not change to 9. And it will keep on moving in the direction it was previously moving. So it will go into this direction. Or assume like we had a different scenario where he was moving to right, he was moving to left, and this had like 20 health, he had 10 health. So this, once the collision will happen, the lower value health robot will be destroyed and will be left with this robot, but now its health will decrease by 19 and it will keep on moving on the left direction. So this is what happens in the collision. And what if their health are equal, right? If the health is equal, so either this will happen, or if not, then the other robot, R2 robot health will decrease, right? And R1X will be destroyed. In this case, R2Y was destroyed, and finally, if they're equal, the health is equal, what will happen? They both will be destroyed. Both robots will be destroyed, right? So they both won't exist. They'll both just vanish. So if we come back to our example, what will happen in this scenario, right? So the first collision we could easily see, right? It will happen between 3 and 4. So who has more health? Third one has 10. This one also has 10. So they both will be destroyed, right? So we will be left with our first robot and our last robot. And his health, right? His health is 15. His health is 12. So what will happen? The lower health one, the last robot, right? It will be destroyed and we are left with the first robot, but his health will decrease because he met a collision. So his health will be now 14. So our answer is 14, correct? So how we are going to approach this one? I think we get an intuition, right? We have to take some data structure where we can add our robots. The moment we get incoming robot that may collide with the current robot, then we have to check for the collision, right? And if not, then we'll keep on adding our robot in the queue, or maybe whatever data structure we are planning to take. So since we have to see what my last robot was, we have to see at the head. So we'll take stack to store our robots, right? In the stack we'll store our robot. Perfect. And we'll keep on adding it, like whichever robot we get, right? We'll check its direction. If it's a first robot, right? And we got anything for, let's say, moving in the left direction. So if my stack is empty, so there is no robot we have seen so far. So this is going to be my first robot. In that case, we'll add it. We'll simply add it, right? We'll iterate on it. We'll iterate on the robots, right? We'll iterate on the robots. We'll have two conditions. One is if collision happen. If not, then what will happen? If collision happens, right? We will check like all three cases of collision. Who is greater, who is smaller, or if it's equal. If not, we'll add it to our stack. We'll add it to our stack. We'll add the robot to a stack, right? So there could be three possibilities I can think of. Either we'll encounter any robot which is moving to the left direction, or we'll encounter any robot will moving to a right direction, right? So assume my stack is at the moment it's empty and we have encountered any robot. Let's take the example itself. So we encountered robot first with a health 2. This robot, let's name it A, B, C and D. Alright. So we encountered a robot. I'll just write it clearly again. Okay. For what was it? 3, 5, 2, 6, right? 3, 5. He was at 10, 15, and I think it was just 12, right? So we encountered our first robot. When we'll start the iteration, we'll iterate on the positions array because that will tell us the robot position, and we have to obviously sort it because it's not in sorted order. It's given that it's not in sorted order. The position may not be in sorted order, so we'll have to first sort it and then we'll start iterating on it, right? So I got the first robot. I'll just name it A, B, C, and D. We got A, and he was moving in this direction, right and left. So we have added it, right? Because this is not any. We'll see the condition of collision, when the collision can happen. We'll again add B, because again B is moving to the right. Okay, the moment we get anything that is moving to left, right, there is a possibility that there could be a collision, right? So what will be the condition for collision? This we have to just identify, and our question will be done. Condition for collision. When can there be a collision? So whenever we encounter any robot that is moving on the left side, right? So what we'll see, if in our stack we have any robot that is at the head and is moving on the right direction, right? Then only a collision can happen. So if I try to write the condition of collision, what should be the first condition? First, my stack shouldn't be empty, right? Stack shouldn't be empty. First thing. Second thing, this, right, whatever it's in my stack, right, st.peak will do, and its robot direction, its direction should be equals to right, and the current one which we are iterating, the current robot direction should also be equals to left, right? This is the case for collision. Then only there is a possibility of collision, right? And then we'll enter it and we'll try to see all the three cases for the collision. So there could be three possibilities. If let's say I'll just name it, whatever we have in the stack is R1, and this is like current one, right? And we can mention it as a previous one, let's say. So if previous robot health is greater than the current robot health, right? So in that scenario, this will be destroyed. So we are not going to add this one into our stack. But this, since we have popped it out from the stack, right, we have to pop it. Prior that entering it, we will pop it, stack.pop, and I will just store it in previous. So this previous hits health going to be decreased, right? Previous health equals to previous health -1. And then we again, this has to go back to stack, right? Because it wasn't destroyed. So we'll just push it back to the stack, push previous, right? That's all. If the previous one has a higher health, else what if the current health is high, right? Current health is greater, right, than the previous health. In that scenario, what will happen? This has to be destroyed. So we won't add the previous one, but this current one, right? This current health has to decrease by 1. So current dot health will decrease it by -1. All right. And else both are equal. Previous health is equals to current health will do nothing. Right? We'll just continue. Because obviously we are not going, because we have already removed the previous one here when we are popping it out, and current we have not added, so we'll not add, and it should be done. But in this scenario, right, this current might get inserted into our stack. There could be a possibility. Let's say we had one element, one robot, which was moving to this direction. Then we encountered a robot which was moving in this direction. So its collision will happen. We popped out this robot and they collided, and this sustained, right? So now it has to go into this stack. So in order to recheck this condition, it might go into the stack, or there could be another possibility of collision. If let's say we had 2 elements in my stack, this could be one scenario, and we encountered a robot which was moving to the left, and another scenario when we only had 1 element, let's say he was moving to the right, and then we got a robot who is moving to the left. In this case, collision will happen, right? This gets destroyed because he has a higher health. Now this has to sit in the stack. Why? Because there is no element in the stack, and there could be no possibility of collision. So we have to recheck if it can go back to the stack. And in this scenario, they collided, it got destroyed. So again, this has to be checked from this one, right? In the next iteration, So if we just do this, we have subtracted the current one, but the next time the for loop will execute, right? We'll go to the next position. So in order to prevent that one, we'll just do I minus minus. So we'll check the previous one itself, right? We won't move from this robot, will stay at this robot, and the next iteration will again check from this one to this one. What will happen to these two? And in the else condition, we are simply adding it. And it should be done. This is the condition for collision, and we have to just write it, and it will be pretty straightforward. And few things to keep in mind, they want the answer into the order where I think they want the answer in the order the positions were given, right? So first, in order to store, because we are going to sort the position array, we have to store these and their order and everything. So we'll create an object, right? And we'll store all the details corresponding to the position, because ultimately from the position we need to get what 3 things. I think the health we have to get, at which index it was previously, and the direction, right? All 3 needs to be, we have to store it. So we'll create an object for it and we'll store it, and then we'll proceed from it, and then we'll sort it using index, and we'll return the answer. Let's move to the coding so that we can understand it better. So we have to sort our position because it's not given in sorted order. So if we're going to sort it, we might lose the corresponding health and direction. So it's better to first store it in an object so that we can access it later. So I'll create a, let's say, robot object. What does robot is going to have? It will have in health and direction and in index, right? It is in which index it was earlier present. I'll create a constructor and health and direction and finally an index. Equals dot health equals to health. This dot direction equals to direction. This dot index equals to index. All right. So now we have to store it. So position and its corresponding health, direction, and index I have to store. So we'll take the, let's take a map. We'll have integer. It will store the position and its corresponding robot. Right. And we'll now iterate on the position, and we'll store it. So for such a 0, I less than positions dot end I plus plus. I will add it to map, put positions I. So it's for its we have to add it new robot, right? It's corresponding everything. So health, then direction, and lastly which index I. For one thing, this has to be in character. Well, so we have added our robots. Now what we'll do is sort it out, the positions, so that we can start iterating on it. We'll sort it. I will start iterating, and type of the 0, I less than position dot length and I plus plus. So first we have to see our current robot, right? So our current robot is robot current is equals to, at this position, which robot do we have? So we can get it from the map.get. This is our current robot, correct? Now you have to check for the collision condition, if it's colliding or not. So the condition was pretty straightforward. This stack, okay, so you have to take stack of it, where we are going to keep our robots. Robot stack, stack. Alright, so stack shouldn't be empty, first thing. Now the previous one, if we peek on the stack, right, the previous element that is in the stack should point to, and its direction, right? Its direction should be equals to right. If it's pointing to right, And the current robot which we are at standing right now, the current dot direction, if it's equals to left, then we have a collision, right? So I'll take a robot, previous robot, we will get it from the stack, st.pop. Two scenarios if the current previous one has a higher health or lower health or equal health with the current one. So if previous dot health is greater than the current dot health, alright, in this scenario, the health will decrease, the previous health will decrease, and we'll add it back to the stack because it wasn't destroyed. So we'll add it. Else if it's the opposite, if current health is higher, then we have to decrease current health. We'll decrease it. And see, this we have to check again with the previous element, if there any previous element. So what we have to do, since in the next iteration it will be I++, we'll move to next robot, right? See, to prevent that, we have to do one I minus, so that it doesn't get to the next robot, because we have to still check for this one. And in else condition, because both will be destroyed, so we'll do nothing, right? So nothing to write here. So else if there is no collision, we'll simply add our robot to current robot to stab. So we'll add it, the current robot. Perfect, we have added our robot. So once it will all be done, we will be left with nothing but the robots which were saved after the collision. Whatever collision had to happen, it happened, and we are left with the robots. So we'll just create a let's say robot remaining robots, new array list and st, right? So whatever's in our stack we had it, we just stored it in this array list. Now since we have to return the everything, the health in the order, it was already present, right? So I think it's in list, right? So let's take the result finally, list integer, the result which you have to return, array list. So we have the robots, and this, right, it will have robots on something in different fashion, this robot and this robot and this robot, but we need then their actual order in which they were given to us. So what we'll do collection dot sort, right? We have to sort this using which values? A dot, based upon its index we have to sort it, right? So it will be A based upon A dot index. Based upon index, it will be sorted. Oh no, not like this. We don't write like this. We write it like comparator. We have to create a new comparator, right? Dot sort. Here we'll write it comparator dot comparing, and now we have to pass our A dot. Using this value, it has to sort it. So once it's sorted, it's pretty straightforward. We'll just iterate on it. Robot. These are remaining robots. Robo. And we'll just keep on adding it. So in the result, we'll just add robo dot their health, right? Whatever health they are left with. It was health only, correct? And we'll return the result. Looks good. Let's try to run it. What did we miss? Char direction, right? It was char only. Dot char at. Okay, sorry. Also we have to compare it, right? Yeah, it's done, and let's submit it. Yeah, it's done. That's also what we took. We took a data object, we created an object to store everything. Then we started iterating on the position after sorting it out. And we checked for the collision. If there was any collision, these two conditions were straightforward. Right? Because we again have to check for the current one. If not, then we'll push it. Whatever will be left in the robots, we'll just sort it using its index. Because we want it in the actual order they have arrived. And then we'll just store it in the result and we'll return it.